My name is Marcos Costa. I'm the coordinator of components of this ProQR project. I am leading the project in the cooperation between Germany and Brazil of the GIZ, the Technical Cooperation Agency from Germany. I'm going to moderate the session today. That's a third of a series of webinars for 2021. So I would like to welcome our partners of ProQR, our financing entity, the BMU, the ministry from Germany, and the Brazilian partner, Ministry of Science, Technology and Innovation, the German Aerospatial Center, DAR, and the Institution of Electrical Research, and our partner institutions that are here today. So thank you so very much for this partnership. The sustainable aviation fuels are produced with renewable energies, water and CO2 to produce syngas. So that this is the most important ingredient for these new fuels. Also, we can use processes from elements from the industry. We have a partnership between ProQR and EP, and there we use the potential of the industry with residues. So the analyzed industries were soybeans, sugarcane, biodiesel, rice, steel, cement, and pulp and paper. And was estimated annual production, and we wanted to map which regions in the country have the biggest potential. These data are very important because they help to determine where it would be a good region to build a plant. In our webinar, we will have today the director of the Department of Applied Technologies from Eduardo Soriano Lousada. We will have the director of studies of oil, natural gas, and biofuels, Heloisa Borges. So assessor of GIZ, Ashkar Nemar, and the research analyst from EPE, Juliana Rangel. And with that, I will give the floor to our first speaker. That's Eduardo Soriano Lousada. Soriano, you have the floor. I have 10 minutes, right? Yes, exactly, 10 minutes. Good morning, everyone. I'm very happy to be here to a new webinar of the German-Brazilian cooperation, and especially in this sustainable aviation fuels. This is very important, the position of the ministry. Our Ministry of Science and Technology is responsible for the management of public policies and research and innovation and other competences. And therefore, the ministry is a very horizontal ministry and helps with tools. As our Minister Marcio Pontus says, we provide tools for many sectors and technologies here in the country. And especially in this project, we are responsible for this project here in Brazil. And to jump right in the topic of syngas. Syngas is a very old topic here in our ministry from the year 2000, where we started working with syngas, and we wanted to produce synthetic fuels, renewables and not renewables at that time. And we made many actions to produce syngas in our ministry. And we had a lot of partner institutions, and this would mean hydrogen and CO2. The CO2 with capturation, with industries. We analyzed which industry would have a CO2 available, the production of hydrogen with electrolysis, or industries that would provide us with hydrogen as a co-product or sub-product. So this topic started in 2000, and we started with a nationwide combustion network. So the name is combustion, but we worked with thermochemical with many projects with syngas. But this was not a very important topic in the country. We had a lot of energy options. We talked a lot of hydrogen, but not synthetic fuels. We talked a lot about ethanol and biodiesel, and we were putting biodiesel in our energy matrix. But this was a very important topic because our actions gave us a lot of competency in syngas of fossil sources, of gas and oil, but also biomass. And we have a lot of groups to work on this topic, not only in the tropic, but we have a lot of different paths, and also to use the syngas. For example, we can use it as a chemical intermediate to produce a lot of products as fuels and chemical products with a high value. In this last years, syngas has changed, as we will see in this seminar today. We will have some sources, and also how this can be used as sustainable aviation fuel, the SAF. And this is very important. Most of the paths use syngas nowadays. So we have some chemical transformations, chemical reactions, like Fischer-Tropsch, and we can transform syngas in a series of products. And that's what we do in our ministry. So we want to help research. We're about to help this research groups and companies, and we want to develop national technology. Of course, we like this international partnership. The project ProQR is very important, and looking at the international scenario, this is one of the pioneer projects that discusses the situation of sustainable airplane fuels. And for this aviation sector, there are still are no options for electricity, not in a short and middle term. So our technologies reached their limit in efficiency, and this is really a point where a good solution would be to work on the fuels to reduce emissions on aviation sector. And this ProQR project is also important for an interesting point. As energy in the past was produced in a centralized form with huge hydroelectric plants, the tendency is to show us some options for a decentralized productions following the model we see in many renewable energies like wind and solar energy. And this can, so we can have a better distribution and we can produce it where it's consumed. We have some difficulties in our market, and these fuels, even if the production is a bit more expensive, this can be a good idea. So I just want to say that our ministry is available. We can help you. And this is a very special year. And for the first time, we could use sectorial funds with the help of the academy and the industries. And we are increasing investments in science and technology in this country, especially in these areas. For example, we are planning at FINEP digital action to promote technological development and innovation in in the company sector, in advanced fuels, hydrogen. We are also doing some projects for some institutions, and we will have good news. We're looking forward to good news. And this is pretty much aligned with our governmental plans and the sector energy and fuels. For example, the program of future fuels, some programs of our government and our ministry. And we have in renewable energy as a priority topic in our government. And the agency, the regulating agencies should focus on topics like biofuels and hydrogen. So it's very important to say that this topic is pretty much aligned in the technical and scientific framework and political framework of our country. Thank you very much. And so I give back the floor to Marcos Costa. Thank you, Soriano. Thank you for your talk. We would ask you to stay with us because we will have a discussion at the end, and then I will give the floor to the Director of APE, Heloisa Borges. Good morning, everyone. Thank you for the invitation, and thank you for the partnership. Thank you, you all, for being here with us. And I'm trying to share my presentation. Always, when I try to share the presentation, I have some trouble here, but now, well, we are seeing your presentation. We are not, that's not in the presentation mode. Yeah, this always happens. Well, it's still wrong. I will try again. And they always say, if you try a second time, you will succeed.
I'm afraid I still have not managed this. Very well. I am now sharing my screen. Marcos, can you see the presentation? If you could please put it on presentation mode. Very well. A good morning to all of you. I'm going to present a brief context of this partnership. I would like to thank GIS for the partnership. Now, EP is a federal agency under the control of the Ministry of Mines and Energy. And the main purpose of the EPE is to provide information studies and research to support the Brazilian energy planning. And because of this, we take an integral approach to electricity, oil, natural gas, coal, nuclear, renewables, and energy efficiency. In truth, energy refers to fuel. And when we speak about the future of energy, this is our mission. When we speak about the future of energy, we have to focus on planning and see how we can contribute to having a cleaner energy matrix, not only for Brazil, and how we can prepare Brazil to face the challenges of the energy transition. I'm going to refer to how Brazil faces this challenge, the Brazilian energy matrix, the project, and some final remarks. We should keep in mind that when we speak of an energy transition, we're speaking of changes in the use of energy, reducing the carbon intensity, and we're speaking of energy in different sectors. Of course, we have different possibilities and technological alternatives. And of course, this will have a greater impact on international trade relations. And this will include the decisions of how we move forward and how we continue going forward. This global effort uh, is linked to a response to the climate change. We want to speed up the pace with the COVID-19 pandemic. We have resumed several of the activities. We're trying to speed up what we are doing, find ways of producing clean fuels at a very competitive scale. When we speak of energy transition, it's important to recall that we do not only speak about electrification or energy, we're speaking of environmental sustainability based on climate changes, but we mainly refer to technological innovation, and the study will contribute to technological innovation studies, sustainable fuel for aviation, a more efficient use of energy resources, digitization, and that search for sources that have a lower carbon source and electrification. When we speak about these efforts, we should recall that this is a global problem and a global responsibility. And the global aviation industry is the one that stands out the most. It is the segment that we identify as being hard to abate, where the electrification solutions are still quite improbable. The global aviation industry produces 2% of all the human induced CO2 emissions. They are responsible for 12% of CO2 emissions from all transport sources. And to abate this, we need to look for solutions. And as part of this search for solutions, the ProQR project came about. With climate neutral alternative fuels through a partnership between Germany and Brazil to develop low carbon solutions. Now, how is this part of the Brazilian energy supply? If we look at the evolution of energy supply in Brazil, we see greater space for biofuels, a greater growth of renewable energy, and we see that we can allow for new fuels to substitute renewable fuels. In aviation, the Brazilian kerosene is imported, and because of the Brazilian tradition of using renewable fuels, we can also work with substitutions and in our international flights. When we carefully examine the potential for substitution that you see here, 30% of the Brazilian energy matrix is for the transport segment. Mostly we use diesel, and this because of a historical background of investments in this type of transport. And in the medium and long term, we're moving towards this, but we're going to focus on QAV 2%. In the graph to the right, you can see the potential for substitution that we are forecasting for QAV. These are the imports, the international demand, a potential of 3.3 billion liters that could possibly replace QAV. The study that we're going to present to you are part of a much broader scope of several projects that have been presented. This is a very beneficial and promising partnership between Germany and Brazil. We have the analysis of the life cycle cost for aviation fuels, the conventional aviation fuels in Brazil. We analyzed the cost component and parameters that we could define in the value chain, and this began in 2018. For the production and supply of aviation fuels, we mapped the existing QAV structures. And in the second study, we analyzed and approached the potential of syngas for the production of sustainable aviation fuel based on the Fischer-Tropsch path or route. We have spoken to several industries. We are thinking about different feedstock and have detected interesting potential for soy, corn, and sugarcane, which have the greatest potential, and regionally potential in the center-western region and Mato Grosso. I'm not going to refer to the conclusions of these studies, but would like to refer to some important points we have in mind when we speak about the focus of this webinar. As we mentioned, this is a global problem. The global aviation industry produces 2% of CO2 emissions. It represents 12% of all transport sources. Of course, road transport is the greatest source of emission. And this is a segment where we have other alternatives for abatement. Now, sustainable aviation fuels are extremely important to mitigate local and global emissions. And the partnership between Brazil and Germany to find a local solution for Brazil is of supreme importance to be able to comply with the Brazilian goals, the global targets, and especially to comply with the abatement and emission reduction goals. I would like to thank the technical coordination, Angela, who is here, Juliana Rangel, who will also make a presentation. I would also like to thank Rafael and the entire team from the Energy Research Office of Brazil, the EPE. Thank you very much, Heloisa. It's always a pleasure to have you here with us. And I would like to give the floor to Ashkan, who will speak about the study per se. He is the author of the document that we are presenting here today. Ashkan, you have the floor. A good morning to all of you. Please allow me to share my screen. Can you see the presentation? Well, thank you very much, Marcos, for being the moderator. I would like to greet everybody and first thank the director Borges from EPE and Soriano from the ministry for his presentation and presence. Besides thanking Marcos Oliveira, I would also like to thank Juliana Angel and the other colleagues from the EPE who have helped me to draft this study. In this presentation, I'm going to present a summary of the potential of syngas production by different industries in Brazil. Here you can see the agenda. In the introduction, I will give you a general overview of the study. I will then speak about the industries that have been identified for syngas production. Ensuing this, the results of Syngas Potential in the industries analyzed, and conclusions and an outlook. Very well, in the introduction, as has been said by prior speakers, we have climate change throughout the world. And to comply with the Paris Agreement, there is the need to decarbonize different sectors, reducing the greenhouse gases. This is an urgent situation. These industries that are hard to abate, like the aviation or sea transport industry. And the solution would be synthetic products generated through renewable fuels and sustainable feedstock. One of them is the sustainable kerosene, the sustainable aviation fuel. Now, the greatest advantage of these products is that they make it possible to use the existing infrastructure while we decarbonize the industries. Now, to generate synthetic products, the Fischer-Tropsch process can be used through a catalysis, and the main intermediate product is syngas. Syngas is a mixture of carbon monoxide and hydrogen that can be generated through direct processes, through a chemical conversion, or indirect processes with a CO2 source, water, and hydrogen through co-electrolysis to generate the gas. Syngas can be generated based on different feedstock. Now, the idea is to generate syngas in a sustainable way using the low-value byproducts of the main industries in Brazil. Now, the idea of creating high added value products is still not being appreciated. And this could, of course, become a transition to a circular economy. The goal of the study was to investigate the production of syngas through the use of residues, low-value byproducts at regional and state level, as you can observe in the map, and to estimate the theoretical value of sustainable aviation kerosene. This is the methodology that was set forth at national level. We initially identified the industries that would be suitable for syngas production, identification, and analysis of byproducts of selected industries to analyze their conventional processes, and at regional level to estimate residues and conversion processes. All of this was mapped at regional and state level. And the next step was find ideal sites, pilot plants, or other plants for the production of this fuel. Very well, we're going to speak about the industries identified for syngas production. Here you see a list of those who can produce this directly through a chemical conversion through gasification, reforming, or pyrolysis. We have the agro industry, agricultural animal waste, bioethanol, biogas, and biodiesel industry, as well as municipal waste. But we also have fossil fuels, pulp and paper, and biomass. Another way of producing syngas indirectly allowed us to identify industries that have a concentrated source of CO2. Through electrolysis with water, the production of syngas is possible. We identified several industries in Brazil: bioethanol, the metal industry, cement, and the chemical industry as well. The question that arose at this point is, in which of these industries is there the possibility that they will continue to exist in the case of decarbonization? Through an assessment matrix and keeping that question in mind, these industries were assessed. Here you can see that the fossil fuel industry has a low probability compared to agro-industry, where demand grows steadily. After this assessment and the use of criteria in terms of production for Brazil and the availability of data, some of these industries were selected and they were analyzed in great detail. We have the cement industry, soybean, biodiesel, corn, rice, and other industries. Once again, I will not go into the details of the processes of each industry, but I will present two of these industries in greater detail. We can speak about the cement industry, for example. The simplified cement process is shown here. Cement is an essential ingredient for concrete with a growing demand worldwide. And we have carbon calcinate as the main component that is used in pre-calcining. There is a use of fuel, the kerosene, and this will generate CO2 and lime. Therefore, for a ton of cement, the cement industry generates 0.05 tons of CO2. And this CO2 can be captured through a carbon capture unit, as you see here in the post-combustion stage. And this is being marketed, and the efficiency of this would be 90%. Because of these factors, and with the annual production of Brazil based on the 2018 production, we estimated the residues and the potential for syngas through co-electrolysis. The same here is shown for the agro industry with soybean and biodiesel. Here you see the feedstock in orange, the process in blue, and the output in green, and the byproducts or residues in gray. During the harvesting of soybeans, there is the enormous amount of straw that includes stalks and leaves that are normally left on the field. And in some cases, they are burnt and they generate greenhouse gas effects. But when we speak about the biodiesel industry with soybean, in Brazil, the main feedstock for the production of diesel is soybean vegetable oil at 70%. And there is a trans-esterification to generate biodiesel and to generate a low-value byproduct, which is glycerin, that can also be used for the production of a higher added value product.
So in this case, we estimate that residues of the industries can use. So for every ton of soybean, we have straw, and for biodiesel, we have 10% approximately of glycerin by volume. These residues were estimated in from the production of this industry. We have a lot of data from 2018 and also for biodiesel, because after the conversion it was possible then to produce the syngas. Now we want to look at the potential, the syngas potential of the analyzed industries. So these results, here we can see the different industries in the first column. They were analyzed by detail, the byproducts and the residues. We have here in these processes, and then the total annual syngas potential in million tons. As we can see, the biggest potential for syngas production is in agro industry. For example, soybean straw, sugarcane straw, or corn straw, especially because the Brazilian has a huge production here. But also other industries can generate a very good, very high potential of this feedstock. When we look at the state level, we can see that the maximum potential of syngas production here is in percentage. We have 53% of this potential of sugarcane in São Paulo state. For soybeans, we have a lot in Mato Grosso. Biodiesel, we have a lot in Rio Grande do Sul state, and corn also Mato Grosso. But as you can see, they are usually in the central east or the southeast of the country. So the total annual potential of all these industries are 193 million tons of SAF when considering all these industry segments. So this is 3 times the demand in Europe, and this fuel in Brazil produced fuel can used for the Brazilian demand, for the domestic demand, and then can also be exported to other countries with a high demand. Now I would like to show you the maps we we could develop with our data system. We have the potential in the cement industry here, regional level and state level on the right side. So on the regional level, we can see that the southeast has a really high potential for syngas production, and on state level, we have the Minas Gerais state with the highest potential. After that, with locations of these industries, of cement industry and steel industry, the first criteria where we here we can see that where we can produce the syngas and where are the airports where we use the syngas. So here, for example, we can see we have Belo Horizonte Airport and a lot of very interesting localizations for a pilot plant. Here we can see soy industry, agro-industry. Here we see on a regional level, and on the right side on a state level for Syngas Potential. So when we produce syngas out of soy straw, we have the highest potential here in this region and in Mato Grosso state. And the same thing here for the soy industry, with a study of the university UFRG. We analyzed the best place to produce syngas, and also where there is a demand from an airport. So now I will quickly come to conclusion and outlook of the study. So the industries for syngas production in Brazil were identified, and some industries were analyzed in more detail. So the analysis revealed that Central West region accounts for the highest syngas potential. This was 37% of the total, that followed by South, East, South, Northeast, and North, with the production in the industry. So the use of agro-industrial residues and straws has the highest potential to generate syngas. And if we consider the potential syngas production of all industries, an annual potential aviation fuel production of about 193 million tons of SAF would be possible, and the potential using residues and byproducts added to Brazil's favorable conditions to renewable energy puts a country at an advantage in the production of SAF. So in the end, I would like to give a short outlook what we can do after this study with more accurate database and GIS analysis under higher spatial resolution, gives better estimations of the potential and helps selecting optimal locations more accurately. And the analysis of the potential of other industries such as forestry, animal waste, biogas, and municipal waste should be conducted and could lead to other interesting regional distributions. And further techno-economic assessments of the different routes, such as their social and environmental impacts, should be assessed. The byproducts used in the conventional process itself, and therefore not analyzed in the study, for example, bagasse or black liquor, could be analyzed regarding their possible viability to produce syngas and high-value products. And in the end, the R&D regarding the conversion of the different syngas production routes is needed. So we need laboratories and pilot plants. Oh, thank you very much for your attention. I believe my time is over. And I would give the floor back to Marcus. Thank you, Ashkan, for your valuable contributions. If you have questions, please ask them in the chat. I would ask Ashkan to stop the sharing, and then we can give the floor to Juliana Rangel for her presentation from EPE, from the Brazilian Electrical Research Company. Good morning, everyone. Thank you for the coordination. Good morning to Ruth and Marcos, Director Soriano, Heloisa, Ashkan, and thank you for being here with us. So I will be the last one to talk, and I really want to highlight the advantages and what this project can bring us. I will show you my presentation, and therefore I would like to share my screen. So can you see presentation mode? Not yet. I'm not yet in presentation mode. Yeah, I'm seeing it in presentation mode. I will share my screen again. So now can you see what I'm seeing? Now we see you. So now I'm sharing my screen, and now you can see it on presentation mode. Yes, that's perfect now. I would like start with the reasons why we are researching this topic. And the first is we really need to reduce GHG emissions, also the diversification of the fuel and energy matrix. And here in Brazil, we really want to reduce the dependence on imported jet aviation kerosene, and we want, when we with the diversification of the energy matrix with other raw materials, we generate jobs for the population and also opportunities. Especially in this study, we can create opportunities for economic and social development in industry in the interior of the country, with consequent reduction of regional disparities. Of course, there are another very important topics related to the cost. We know that biofuels, the raw material, the cost of the raw material is the most important for production. And this reflects on the price of the biofuel. So we need now to identify how we can find raw materials, alternative raw materials, residues, byproducts of the industry. So then this syngas, this synthetic biokerosene, can be competitive with what we have today on the market. And we see the cost of certification can increase production costs and impact on productivity, on competitiveness. But if the production is gets together with other products, the competitivity of this product in the market can be increased. So as we talked about the prices, it's very important to highlight this comparative. So these are informations from Prats. I believe we have a microphone on. So here we can analyze the price difference between sustainable aviation fuel and the traditional jet fuel price. And when we compare the prices, we can see in 1 year very huge price differences still. And as I said, here we can see in the beginning from a spread from with 4.3, and then we have in the end a spread of 5. How can this sustainable fuel can be more competitive? Therefore, we need alternative raw materials. Here we can see the increase. So we can see a high price in the domestic market, and we need to find a way to reduce the costs of these products and these raw materials. So the whole world has initiatives to find alternatives for aviation market. We know Corsia, we mentioned these initiatives many times for neutral growth from 2020 with many instruments, and one of them, the sustainable fuels. Here in Brazil, we had the initiative that's a Brazilian plan, Renova Bio, to reduce carbon intensity of Brazilian matrix by expanding of the use of biofuels. In the same year, we created ProQR. This is to create in Brazil an internationally usable reference case of production and application of power to liquid sustainable fuels for aviation. And the newest here in Brazil is this program Combustível do Futuro. So here this is to increase the use of sustainable fuels and low carbon intensity in the Brazilian market. And in this initiative, we have the subcommittee created just to study how sustainable airplane fuels can get into the market. So Heloisa said we are partner of GIZ. We had the first study in 2018, and once again this partnership was very good for us, and we were on board on the second study. We saw already this pyramid here. We want to highlight the most important points of our project. The first thing is we wanted to analyze the potential of Brazilian industries to produce syngas from its low value waste and byproducts. But also we wanted to see not only industry exists, but this production needs to exist also in the future. So we needed to look which industries are will probably stay in the future. So Brazil has a lot of agribusiness. This was really an important point. Also, we have also industries that are very important, like steel industry, cement, pulp and paper. Also, all these industry we analyzed, and this is important to highlight. The first note, the first score for the potential was exactly this, how this goes into the future.
Another significant highlight of the project, if the raw material is so important for the production of fuel, we have to focus on the cost of the process and the cost of the product. And among this huge diversity of industries that are being used, we need to see which will be the residues, which is what is not being used in the industry and that could become a high added value for us in these different industries that have already been shown by Ashkan. In the different industries such as soy, rice, sugarcane, corn, steel, and the pulp and paper industry and cement industries, we surveyed which could be these residues that we could use for the production of syngas, the potential of the country and the regional potential for each of these industries. We studied to see which state would have the greatest potential and the production potential that we could find. I would like to highlight a map that has already been presented by Ashkan, especially for soybean, which has the highest potential, as we saw in the previous slide. Soybeans have enormous potential for the center-west region, and especially for the state of Mato Grosso. There is an enormous potential for syngas production for this crop in that state. What we should reflect upon, and this is the vision of the EPE and the studies that we carry out, is to think about the future. I have brought you some data from CONABI, the Ministry of Agriculture, to show you the growth of these crops, the growth of this production. We have 4 figures that refer to the production of rice, soybean, corn, and pulp. The forecasts that have been done by CONAB point to the fact that on average, this production in the next decade will grow by 30%. Rice will only grow 3.5%, but all of them will have average growth of approximately 30%. If we look upon this in this way, what we observe is that if this production will have a growth of 30%, we will also have a growth in the production of syngas. If we could forecast the growth of syngas, as production will tend to grow based on residues and byproducts in this industry will also grow, we will have a enormous potential to explore syngas in those markets. What I would like to underscore at the end is the evolution of sustainable aviation fuel throughout the world. ICAO highlights that presently we have 35 airports, basically concentrated in North America and Europe, that are presently distributing sustainable aviation fuel. It has also identified 18 policies that have been adopted worldwide. Among them, we have Renova in South America. We have a contract already signed for the supply of sustainable aviation fuels. representing 16 billion liters for the coming years. In terms of process, we have 8 certified conversion processes for aviation fuel, and one of these processes is the Fischer-Tropsch, which was analyzed with a greater focus in the study. ICAO also points to the fact that we have over 360,000 commercial flights with the use of sustainable aviation fuel. What we hope to see in the near future is that we will be ready to take off using sustainable aviation fuel produced within the ProQR project. Once again, I would like to thank all of you, thank the project team, and thank the team of EPE as well. Thank you very much. Thank you, Juliana. We will now go on into a more interactive stage with the audience. I would like to ask the speakers to please turn on their cameras, and I will ask Ruth Barbosa to act as a moderator for the questions in the chat. And after the interaction, we will share with you our agenda for our series of webinars. You have the floor, Ruth Barbosa. Thank you very much, Marcos. A good morning to all of you. Now, while these presentations were being made, we already had good interaction in the chat. João Faber from GIZ will present the third question here, if possible. And the question is, which is the energy balance for the transformation process of CO2 reform into syngas if the final balance is positive when we speak about aviation kerosene? Ashken, would you respond to this? Thank you very much, Ron, for the question. Yes, I can respond to this and say that in this study, we analyzed, perhaps not in great detail, the energy balance of these different accounts. We still require a technical and economic study compared to other routes such as electrolysis. We require more energy than in gasification or reforming. The balance continues to be positive, but compared to others, we would require more energy, in this case, renewable energy. I hope that this has responded to your question. Thank you, Ashkan. We have 3 questions. We're also going to respond to the question of Marcio from Sao Paulo, from the Innovation Group. He asks about aircraft that can use aviation fuel that will be flex fuel, if those that go on international flights can be supplied with syngas in Brazil and normal kerosene in another country. Who would like to volunteer to respond to this technical question? Soriano, please. Well, in truth, an airplane does not fly with syngas. It flies with aviation kerosene. Syngas is an intermediate product for the production of airplane fuel. This is an important distinction. Syngas is a fuel that is used in some processes, but not in aircrafts. Well, aircrafts know which is the fuel that they're using. It's a drop-in fuel, and there are ASTM standards that allow for certain blends depending on the technological route. At the beginning, Some routes will enable for a blend of 10%, 20%, or 50%, but this is a process. And these fuels will clean up the combustion in the turbines of the aircraft. This is how syngas works. Once again, syngas is not a multi-fuel or flex fuel as we use in vehicles where we can use gas or alcohol in any blend between 0 and 100% of ethanol and gas. This fuel has to be galvanized. And I remind you that aviation has extremely stringent rules, and we joke that there's nowhere to park when there's a failure in the machine, differently from normal vehicles where we can stop on the highway. This is a very serious issue. Also, the fuel has to be similar worldwide because airplanes have greater mobility. One day they will be in New York, the next day in Brazil, and the coming day in Portugal. And on Tuesday and Wednesday of next week, they might be in Tokyo. Therefore, the fuel has to be uniform and galvanized. Thank you very much, Soriano, for the explanation. We will still have several different occasions to study this technology and innovation. I give the floor to Felipe Garcia, who mentioned in the chat one of the presentations. It seems you raised your hand. Thank you, Ruth. And I would simply like to add something to the question raised about the flex turbines. In the aviation market, we are faced with a rather curious situation. The aircraft engines have been developed keeping in mind fossil fuels, of course. There has been evolution in terms of the specification of the product, of the fuel itself, as well as the propulsors of the engines. There has to be harmony between the products and international harmonization, as mentioned by Soriano. It's important and necessary that the fuel being sold in Brazil be compatible with the aircraft and with what is being used elsewhere in the world. Alternative fuels are here to become part of the scenario. And from the regulatory and technical viewpoint, we have to have safety, know that different fuels will in fact be fully compatible with what is being used by aircrafts in operation worldwide. What ASTM and national regulatory agencies are following up on are these discussions. And we set forth specifications with fossil kerosene, 100% alternative, and the maximum blends that would be authorized for all of this based on what is set forth by the ASTM, which is the international forum for these discussions. Technical assessments for the compatibility of these new fuels with the aircrafts and the material used in the aircraft all have to be done with full safety, the safety demanded by the market. Well, this is what Soriano mentioned, and of course, all of this is being followed. If you have a fuel failure in flight, this is a very complicated situation. And in the aircraft segment, there are procedures that can be used and that offer safety to the market. But of course, these are situations that are exceptional. Nobody wants to be in flight with the 4 engines turning off and the pilot being forced to land without an engine. Of course, it is possible to bring the aircraft to land, but this is an exceptional situation. And what I included in the chat is a reflection on the study that was presented. It's very interesting because speaking about the potential of feedstock for the production of syngas and to work with syndex as an alternative in alternative uses is a very important study. Based on what was said, we have enormous potential in the center, west, and southwest, and this would gear us towards a centralized production of this alternative fuel. As far as I was able to understand, this perhaps we should consider a central production of this feedstock and ensure that this feedstock will be produced in a decentralized way with full price competitivity. And up to this point, we have not worked on the economic feasibility. It would be necessary to survey this to assess the options in the future.
Thank you, Felipe Garcia. Felipe works at EPE, and that's why he is bringing this information. And I think it's very important to have this information. So before I give I just want to interrupt because it's important also to say the next study we're going to do with GIZ and EPE is the technical viability to build refineries out of residues of sugarcane industry, biodiesel industry, soybean, and we're also doing a study in this work line with other industries, with other residues. So this is important, and this is already on our radar, and we're really studying the technical viability for this, and also to identify what other products can be used together so these processes can be economically viable. Thank you, Juliana. Marcos, do you want to complement? Perhaps you can just give us an outlook about the next activities and next steps of the project and in the end. Yes? And I will just have a look at the next questions. Jacqueline, you can turn on your microphone and your video and just ask your question. Good morning. I work at the Secretary of Civil Aviation. So congratulations to this very good presentations. I just have a question still. You identified Mato Grosso state with the highest potential because of soybean production. And do you have already a strategy? Is something being developed with state government to have a pilot project? As Philip said, um, you will need a refinery. I would like to have more details about this, or if this project is uh, being identified only, or if you already have a program, a pilot program, if something is already developed with state government. Thank you. Thank you, Jacqueline Gonçalves, for your question. And perhaps Soriano can answer this, and Marcos can comment a little bit. Yes, I will answer some of the questions. The first important thing was raw materials. The raw materials are responsible for a great part of the cost. For example, by biodiesel, 70 or 80% of the costs are material costs, and therefore this study is very important. This is one of the feedstocks, the most important. Another point that I believe it's very important, when we talk about alternative fuels in Brazil, we think always about bio. The ProQR product works also without a project, works with fuels that are not biofuels. So biofuels are all the renewable routes. So electrolysis, hydrogen, the CO2 capture. So here we have no byproducts, but of course you can start with an electrical route. You can take CO2 with fermentation of the sugar cane industry, and then you can produce a hybrid fuel that's fuel with a renewable content. That is important to understand, because we always talk about biofuels here in Brazil, but we are now talking about synthetic fuels. Raw material is very important, but it's not the only topic. We have technological questions. We need technological setting, we need distribution, we need logistics. There are many elements important for this decision. What we are doing today, and perhaps Marcos can give some details, we are seeing about, we're looking at possibilities. We can have, of course, state components, but the idea is look in a regional way and not in a state program. So, because sometimes the state is not, um, would not be the best view for this. Sometimes we see a state that wants to be a candidate and gives incentives, but sometimes technologies are in other states. So we are really looking at regions. Where do we have initiatives? Where do we have um, private initiatives? They are most suitable, and sometimes it's not a state project. So state companies and state raw material, we want to look further than this. And in parallel, the ministry, as I said in the beginning, we are launching a lot of incentives in the next months to innovation for academy, for companies, and some research projects specifically using some routes for renewable and sustainable aviation fuels. This is very important. And important also is to understand that the costs are higher always with every new fuel that's coming into the market. So solar was very expensive. Now it's competitive. The same with wind energy. And these routes, they use residues. And this is very important. So you not only reduce your emissions, but these are environmental services. So you use residues to develop a product. Um, Perhaps you would like to give the floor to Marcus and he can give some details. Yes, thank you, Soriano. Marcus. Yes, the interactions are very, very interesting, and I would like to thank you all for your participation. And I would like to just highlight some initiatives we are doing. We have components, we have pilot plans, and we are looking for partnerships to do these projects. We have 5 initiatives that are being negotiated. For example, a partnership with Biogas to produce biosyn group. This would be the following product after syngas on the biomethane chain. Another partnership is to use glycerin from biodiesel to get aviation kerosene. We have another partnership with the University of Goiás to use residues from agriculture to produce synthetic oil. We have no partnership with the states, but since the beginning of the project in 2017, we have been talking to many regions here in Brazil. Thank you, Marcos. And I would, yes, and I will ask Professor Claudio Mota. Yes, good morning, you all. Congratulations to GIZ to organize this webinar. I am director of the chemical department of University Rio de Janeiro and have been working in this area. And this context, this general context of syngas, of biomass, is quite old in the BTL, biomass to liquid. And as I know, and perhaps other people can give more details, one of the biggest problems is logistics, because you can use solid wastes and they're very difficult to transport. That's not like a gas or a liquid when you can bring with under pressure. As I understood, you need to have a regional production. You have a high potential on the Central West or in São Paulo state from soybean and sugarcane. But this is also, you have these products on small farms. you need the logistics to collect all these residues and to bring them to one place to build a plant. I don't know if you're considering this question, because this seems that could be limit such an initiative in a regional. So you would have regional plants, and one of the goals of ProQR is a decentralization. So the possibility to produce syngas or kerosene in Amazonas or in the center of Amazonas state, and this is very complicated. So perhaps the route, as Soriano said, to have a direct capture of CO2 could be more interesting. And I would like to ask this logistical aspects for the transportation of residues or waste. Did you consider these aspects? Or do you want to consider this in a second step? Because I believe this is a very, very important point, just to decide which route would be the most interesting, because we need to look at the waste. Yes, thank you, Professor Mota. And to give an overview, we are coming to an end in our event, and I will give this question to Ashkan. He did the study, and then we will have a contribution from Marcus and Professor Luis Ramos, and then we will really come to an end with our event. Ashkan and Juliana, did you consider decentralization? Thank you. Yes, I can start and Juliana can complement. Thank you for this question. This challenge was already mentioned in the study, but as I said, it's very important to do technical, economical studies to analyze the different routes, especially really regarding this logistics, the energy demand, where the potential is higher. But this, and sometimes there are problems to clean the gas, to collect residues. These are challenges, and sometimes other routes will be more viable. That's just it's very important to do some economical studies about this decentralized production. These studies can show which industries can generate this syngas, but of course we can see that the potential of renewable energies is in the northeast. So there we have the lower cost. So I believe we need to check other industries, we need to check and where we don't have waste, for example, in the Amazon, we can generate syngas out of renewable energy, water, and CO2, and this from the air can be a solution for these faraway places. So the study just wanted to show where the potential is high here in Brazil, but of course all the other questions, all the other aspects need to be considered. And Heloisa want to say something about this? Yes, perhaps you can. Juliana will be very quick. Thank you, Professor Mota. This is very important and this needs to be analyzed because it is difficult when we compared this with liquid or with gas. Really the transportation costs are higher. But the first study we did with EPE, we focused on the demand. Where do we have a higher demand and where do we need to produce this fuel? In this study, we focused more on logistics. In our second study, we are just looking about the availability of syngas. So this is where we have availabilities. Now we will have to complement these studies. So I can identify where do I have this available when I cannot produce this and when I have no demand. So the study is ongoing and we believe that what the professor said is very, very important. But two other aspects are very important. We are working, some industries are working, we're working on waste, agroindustry, for example, with solid waste, and other industries we are working with CO2 as a waste, as a byproduct. And we have some fixed production, and then I can put my plant I can build my plant together with the steel industry, for example, cement industry, where we have CO2 as a byproduct. So this combination, CO2 emission in a high volume on a certain place is a possibility, and then of course we need to combine this with the demand of this fuel.
Thank you, Ruth. I will speak very shortly. I would like to thank you for the comments and highlight an important issue in this partnership with GIZ. The work continues on through studies to be able to bring to energy planning all of this potential for reflection. The fact is, and this is a reality, that we need to guarantee or at least hope that the energy transition will be done within a framework of sustainable development with low carbon use. We do have goals for civil aviation beginning in 2027. It will be mandatory to offset or reduce emissions at that time. And one of the ways of fulfilling this target is through sustainable aviation fuel. If we don't begin to think about that now by identifying all of the challenges now, and if we don't prepare ourselves to build new roadmaps to get to the year 2027 with refineries ready to deliver this fuel, we will have a serious problem in 2027. We can't begin to think about this in 2026. We have been working jointly with GIZ and the Brazilian government in the construction and mapping. We have a series of studies since 2018. This is the 2020 study. We are making strides. We're moving towards the next step of the studies. But once again, with that vision of what it is that we have to do to build and deliver solutions from the viewpoint of energy planning to be able to reach the year 2027, complying with our decarbonization goals and perhaps contributing to other partners in South America and Brazil. And simply to complement this, Ruthie, we have additional visions in this process, and this is the advantage of having an integrated energy matrix. The program Energy of the Future is advancing in this theme, bringing in a great deal of expertise. Everything is still on paper, of course, it's good, but it will be adopted and implemented. We're bringing in important conclusions into our public policy, and we're thinking of synergies when it comes to sustainable fuel, assessing other potential fuels for the diesel cycle as well. And I underscore that all of this is part of an integrated discussion. We need to resolve all of these issues, but we also have to have a great deal of clarity that we need to deliver a solution for sustainable fuel in the long term. Thank you very much. Thank you, Heloisa, for your comments. Marcos, it seems that you would like to complement some information. We're coming to the end of our event. In the question that I just responded to in terms of interaction with state governments, in the state of Paraná as well as in the state of Ceará, we are holding a dialogue with institutions working with this model. I had forgotten to mention that. With this, I would like to invite Professor Luis Ramos. He had raised his hand. Please, you can make your comment now. First of all, thank you for this opportunity. Please excuse me for not having participated in the meeting, but of course my responsibilities as a professor came first. I do regret this, but will listen to the presentation subsequently to understand the content and the reach of your discussions. I have asked for the floor to transparently speak about the activities that we are carrying out in Paraná. Approximately 2 years ago, we began working with renewable hydrocarbons and with, it's called MAP HCR. Now, this MAP involves several universities, including the Federal University of Rio de Janeiro and Biogas. And as partners, we have several international organizations that are greatly renowned and are working with us in projects, in memorandums, or the execution of the project per se, as mentioned by Marcos. These institutions are working on different lines, everything very much aligned with what was mentioned here. And the idea is to transform organic residues into wealth, such as hydrocarbons and other low value added products through the Fischer-Tropsch process. Our process works with biogas from the anaerobic process. We have become large generators of biogas in Paraná that has enormous potential for this. And everything we are doing here will have a nationwide impact. We're working with biomethane, the gas, and the off-gas possibility that is obtained through the purification process of biomass to reforming, which is a technology that is the most appropriate. This is a practical project. This project has support from several industries, and the motivation is to create niches where we can create a unit to demonstrate the viability of producing this biogas. Now, the idea, once again, is decentralized, as mentioned by Professor Mota. This biocrude stabilized through some mechanism can then be transported to other units that would be responsible for the processing and the creation of other interesting products. This is the concept of this new project. We're presently working on our homepage, and very soon we will be sending out an invitation nationwide to all of those that are present here and to others that would like to interact with us in the Araucaria platform, where the NAB HCR group is located and has a discussion forum. Thank you very much for the opportunity, and I do apologize for the speed of my comments, but this is the motivation to make our activities ever more transparent. Thank you very much, Professor. And I would now like to end this cycle of questions and answers. I am impressed with the level of interaction and interest. And I wrote in the chat that we have another webinar that is being planned with Marcio Viborg, who was present here, and I would like to take advantage to invite you to another dialogue about the ProQR project that will be on October 27th. This will be webinar number 4 of our project, where we will speak about the engagement of academia in technological development for sustainable aviation fuels, to learn about the decarbonization process for sustainable fuels. We would like to present the didactic material that is being developed and inform you on the interaction that we have with the professors that also participated in our discussion. And as always, we invite you to please register through the email. We will do this event with translation into English. With this, therefore, I would like to thank all of you very much, and I give the floor to Marcos for the closing of this event. Thank you all for your presence. What we wanted was to give the floor to all of the speakers for a final message. I'm afraid that because of time constraints, this will not be possible. On behalf of the ProQR project, thank you very much for your participation. Our special thanks to the Ministry of Technology, to the EPE for the partnership, Dr. Luis and Juliana, with whom we have conversed a great deal to come to these results. Our thanks to Ashken, who was a trainee at ProQR, has returned to Brazil and is now very important for the project. Thank you for the partnership, the contributions, and the interaction. Should you need more references, you can find this in the link at the project website. Do speak to us. We are at your entire disposal. Thank you very much.